Okay, this is the chapter 2 stuff. So since a lot of these are multiple choice, there's a lot of, charts and things like that. I'm just going to be going back and forth between putting the actual test and then doing the work. So first one, we're looking for domain and range. So I want to actually point some things out here. So finding the domain, that is all of the possible x values. Domain would be the 0, the 1, and the 2. And so these ones are out. That's the wrong domain. These ones are still good. Now, the way that testing if something is a function works, something is a function if every x value goes to only one y value. So 0 goes to 0, 1 goes to 1, 2 goes to 0. This is the thing that freaks people out, is that 0 is going to 0 and 2 is going to 0. That's fine. Two different x values are allowed to go to the same y value. And the example I gave you guys is with height. This would be like one person having a height of 0, which, that doesn't make sense, but you know what I mean? And then someone else having the same height. That's totally fine. What's not fine is one person having two heights. So this is a function. So that would be letter C. You've got 0, 1, and 2, all the possible x values, and then it is a function. Oops. Okay, so number 1, that would be letter C. 0, 1, and 2, and is a function. Okay, number 2, again, we've got a table. So let me go off this again. Shows the annualized percent return of mutual fund. Find the range of the relation, then determine if it's a function. So now the range is all the possible y values, opposite of the domain. So these 4 values right here make up the range. So it's one of these. And then same thing that we were looking at to see if something is a function. The year 1 can only go to 1% return. Year 3 can only go to 1. Year 5 can only go to 1. Year 10 can only go to 1. So this is totally fine. This is absolutely a function. So that would be letter G. Now, if you think about this one in terms of like the context of this problem, it's not possible for like 1 year to have 2 different percent returns. Each year you only have one value for that number. So this is definitely going to be a function. So that would be letter G. This is the range, all the possible y values, and then it is in fact a function. Okay, next one. Find f of negative 1 if f of x equals negative 3x minus 5. So this is some function stuff. This is the first time that we've seen this f of x notation, and we've been doing this for a while, so hopefully this is pretty easy. F of negative 1 means I take this function right here, and I replace every x with a negative 1. So we've got negative 3, replace the x with a negative 1, and then minus 5. So negative 3 times negative 1 is 3 minus 5. And that leaves me with negative 2. And negative 2 would be letter C. Okay, f of 0. So very similar thing that we're looking here. It gives us a different function. F of t. Now we have a different variable, which is totally fine. So here's the function that we're given. We're asked to find f of 0, meaning each t gets replaced with a 0. So now this is 0, this is 0, and then we should have minus 2. So that also gives us a negative 2. So this one is letter J. Which equation is linear? Okay, so we've got to look at the options here. This one is not linear. You can't multiply 2 variables together. This one is not linear because you can't have a squared. That's a quadratic. This one looks good so far. Let's check D. D is not linear either because y can't be squared. So C and D are out because they have squared terms. A is out because it's the multiplication of 2 different variables. So B is the only one that's linear. Oh, again, which is a linear function? So f is out because we've got an x cubed. This one seems okay. This one's not okay because we have 1 over t. We can't have variables in the denominator. And this one's not okay because we have a variable under the square root. So that leaves h. Even though it's in a different format from what you're used to, that one's still linear because it doesn't have, square roots, variables in the denominator, powers other than 1. So that one would be h. Write y minus 4x equals 7 in standard form. Okay, so knowing how to write in standard form, that's a big thing. So standard form looks like this. It's ax plus by equals c. Couple things. It has to be in this particular order. A has to be positive, and then all of these have to be reduced. Like a and b and c can't have a common factor. Like they can't all be multiples of 2 or something. You'd have to reduce that down if they were. So first of all, I'm going to switch these, put them in different order, so that the x goes first and then the y. So I'm close to being in this form, but one of the things, like I said, is that this term right here has to be positive. So in order to make this positive, what I'm going to do is I'm going to divide everything through by -1. So we have a positive 4x minus y equals -7. Last thing to look for is make sure there's no GCF, and we're good here. Because 4, 1, and -7 don't have anything in common. So that matches with letter A. Okay, x-intercept. So we've got -5x plus 10y equals 20. So we've done in multiple chapters now finding the x-intercept and the y-intercept. The x-intercept is where our graph crosses the x-axis. When we cross the x-axis, our y-coordinate is always 0. So that's how we find x-intercepts, is we plug in 0 for y, and then we solve for x. So this term is just 0. So I've got -5x equals 20. So I divide both sides by -5. Okay, so I end up with x equals, this leaves me with -4. All right, and -4 is letter J. So it works the same way for y-intercept, except just the opposite. For a y-intercept, you would plug in 0 for x and then solve for y. Okay, on to slope. Find the slope between, we've got the point 0.2 and then the point 0.88. So let me write down the slope formula for you. So we always use m for slope. We write y2 minus y1 over x2 minus x1. So change in y over change in x. That's our slope formula. So we put in the second y value, which is 8, minus the first y value, which is 2, over the second x value, which is 8, minus the first x value, which is 0. So 8 minus 2, of course, is 6, over 8 minus 0, which is 8. You always want this in reduced form, so you can reduce it down to 3 over 4. And 3 over 4 would be letter C. If a line rises to the right, all right, so here's all your options here. If a line rises to the right, meaning the slope looks something like this. It's not a slope of 0, because that would be a straight line. It's a positive slope. Let's look at the other ones here, though. Negative looks like this, like going down, and then undefined would be a vertical line. So a slope of 0 would be horizontal, positive slope rises to the right, negative slope falls to the right, and an undefined slope is a vertical line. So that would be letter G, positive. So a couple of these questions are kind of just getting your conceptual understanding, which is good. All right, what is the slope of a line that is perpendicular to this graph? Okay, so we can talk really quickly about parallel and perpendicular. If two lines are parallel, it means they have the exact same slope. So it shares this 2. It could have any y-intercept in the world. So if something is parallel to this line, we just care about its slope. We don't care about the y-intercept. If something is perpendicular to this line, we do the opposite reciprocal slope. So a perpendicular slope, that's the symbol for perpendicular, and then we use m for slope, would be the opposite of this, which would make it negative, and then the reciprocal of 2, which means we flip the 2 down into the denominator. So the perpendicular slope would be a -1/2, and that's letter A in the multiple choice. Line A through 2, 3 is parallel to line B with y equals 1. Okay, so line goes through 2, 3, and it's parallel to the line y equals -1, which point also lies on line A. Okay, so this one's a little bit tricky. So it's parallel to this line. Let's talk about what this line actually is. If it's just a y equals, remember y equals lines are horizontal. So here's our line. There's the line y equals -1. So if this line is parallel to it, that means it's also a horizontal line. And it gives us a y value right here. So the horizontal line that goes through 2, 3 is the line y equals 3, which is right here. So y equals 3, y equals -1. Notice they are in fact parallel. This one goes through the point 2, 3, just like we were talking about. And so it gives us options here. Which point also lies on line A? Well, we know it has to have a y value of 3. This does not have a y value of 3. This one does. This one does not. This one does not. So that leaves us with letter G. So again, because this is just a y equals, we know it's going to be a horizontal line. And so this one has to be a horizontal line if it's going to be parallel to it. Okay, next page, 13. Write an equation in slope-intercept form with a slope of -4/5 that passes through the point 0, 7. Okay, so let me write down this point slope form. So it looks like this. We've got y minus a y value equals the slope, and then times x minus the x value. This is a good formula to have if you've got a note card. So y minus, we plug in our y value, which is 7, equals the slope. So this is where we plug in the negative 4/5, and then in parentheses we do x minus the x value, which is 0. Okay, and then we simplify that up because remember they said they wanted it in slope-intercept form. So on the right-hand side, I can distribute that negative 4/5, and this is just 0, so it doesn't do anything. And then last thing I'm going to do is add 7 to both sides. So I have negative 4/5 x, and then I added 7 to both sides, so it looks like that. So I do have that as a choice. That would be letter D. And this, we actually didn't need to go through this whole process, because if you noticed from the beginning, this actually is a y-intercept. The reason we know it's a y-intercept is because we have 0 as the x-coordinate. So knowing that's a y-intercept, we could have just plugged it right into this form. That's the slope, that's the y-intercept. Okay, another equation in slope-intercept form passes through the point 0, 1, and it's perpendicular to the line y equals 2x. Okay, so just like I explained before, this actually is the y-intercept. Okay, so that's b in the y equals mx plus b form. And then knowing that it's perpendicular to this line, perpendicular, remember we just talked about how it's the opposite reciprocal. So that means the slope has to be negative 1/2. Opposite makes it negative, reciprocal makes it 1/2. So I know my slope, I know my y-intercept. So I plug in the slope times x, and then plus the y-intercept. So that would be my line for number 14, and that matches with letter J. Okay, scatter plots. Let's get our data on here. So scatter plot, to draw a line of fit, describe the correlation. So we're going to set up a little scatter plot here. So x values, y values. So the first point is the point 0, 2. So let's scale by 2s here. 2, 4, 6, 8, 10, 12, 14. So we go up to 16. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have the point 0, 2. The next point is 1, 3, so halfway between 2 and 4 there. 2, 10, right there. 5, 12, so here's 5, and we're up at 12. And then 8, 16, it's right about there. Okay, so that's what the scatter plot would look like. And then it says to draw a line of fit. So if we were to draw a line of fit, we would just be estimating it. And it would look, maybe something like that. The points aren't super close together. The important thing they want you to notice in the multiple choice is whether it's a positive correlation, a negative correlation, no correlation, or random correlation. This definitely appears to be positive. As the x values are going up, the y values are going up. So that would be letter A, positive. Okay, 16, we've got a scatter plot right here. So this is one where we can just look right at the multiple choice. So here's a scatter plot, it's got a line. Which equation could be a prediction equation for this set of data? All right, so looking first of all at where the y-intercept is. The y-intercept looks like, if we're cutting through here, this is 50, so it's going right in the middle. That might be about 25. And so this one's looking pretty good so far, but we want to look at the slope. So this one's definitely out because we don't have a y-intercept of negative 50. But if we look here, every time we go up 1, like up from 150 to 200, that's a rise of 50, then we have a run of about 12. So our slope is somewhere like 50 over 12. 50 over 12 is not that far off from like 50 over 10, which means the slope would actually be closer to 5. So J is the closest prediction equation. And let me show you, I'll show you some work for what I did there. So looking at like this point, for example, compared to this point right here. So this point right here is 24 and then maybe like 145, I don't know. And then I looked at this point right here, and that point is 36,200. That's right on the corner. Okay, so if we calculate an approximate slope, we do 200 minus 145, and then over 36 minus 24. So 200 minus 145, that's 55, and then over 36 minus 124, that's 12. So if we take that, I mean, it's going to come out to be a decimal, and we're not going to have that decimal approximation, but just to get close, 55 divided by 12 is about 4.58. So if you're looking at your options, this isn't even close, this isn't even close. Must be one of the 5s. The y-intercept definitely is not negative 50. We eliminated that earlier. So J is the best option. Maybe not perfect, but it's the best option out of the ones that we were given. 17, banquet hall has tables that can seat 8 people. The number of tables needed depends on the number of guests. What type of special function models this situation? So linear function, now here's the thing. If we have 4 people, they're not going to bring out half a table. So it's not a linear function. Step functions are the ones where you have like a step, and then it jumps to another step, jumps to another step. The example that we saw in the notes, I don't know if you guys remember this, it was about newspapers. It was like you get $5, I think $5, I don't know, for every full box of newspaper. But if it's a partial box of newspaper, you don't get any. So this depends on the number of guests. So if they're anywhere from 0 to 8 people, you need 1 table. If they're anywhere from 9 to 16 people, you need 2 tables. From 17 to 24 people, you need 3 tables, etc. So this is definitely not absolute value either. It's not constant because you don't need a constant number of tables. It's actually a step function. So every time you add 1 more person over a multiple of 8, you need a new table. But adding on new people doesn't give you like fractions of tables. So this fits in perfectly with the step function. All right, and I can give you like a quick model of what that would look like. If you go from 0 to 8 people, you would need 1 table. And then as soon as you get that 9th person, you would need a 2nd table. So then from 9 to 16, you would need a 2nd table, and then, from 16 to 24, you would need a 3rd table. So if you're looking at this, you could use this graph to say like, oh, okay, I've got, 19 people. How many tables am I going to need? Find 19, go up here, and you're going to need 3 tables. All right, so that's just a quick model of what that would look like. Number 18, identify the range of y equals the absolute value of x. So this is the function that maybe we know what it looks like, maybe we don't. This is the absolute value function. It looks like this. It's like that V-shaped. Right at the origin, looks just like that. So the range is all the possible y values. This is the lowest possible y value. Notice you don't have any y values down here at all. So starting with 0, it can only go up from there. So that would be any y value has to be greater than or equal to 0. And if you're looking at the options, that would be letter G. Okay, so we've got this right here. It's the region blank, the graph of the line y equals 2x minus 1. Okay, so this one, I know obviously it's multiple choice and we should be able to just pick out one of the phrases. I want to actually graph this just so you can see exactly what it should look like. So set up our line here. So we've got a y-intercept of -1, which goes right here, a slope of 2. So we can go up 2 and then over to the right 1, up 2, over to the right 1. So our line looks like that. Because it's got a greater than or equal to, it's going to be a solid line. And then the way that we do these is we check a test point. So 0, 0 is not quite on the line there, so we can test it out. So we want to know, is 0 greater than or equal to 0 minus 1? So is 0 greater than -1? Yes, it is. So that means that we're going to shade over here. So we probably could have answered it before, but now that we've got this in front of us, it's on or above that line. Could be on the line. That's why it's a solid line, so that eliminates C and D. But it's on or above, and so that matches with letter A. Okay, let's look at the options for number 20. So this is one of our absolute value graphs. So we have, first of all, a whole different host of possibilities here. This is the graph. It's definitely the absolute value of x minus 3. Notice that that part is the same for all of them. It's the normal absolute value graph, but it got pushed down 3 units. They're trying to get us to figure out what the inequality symbol is. First thing I want you to notice is that this is a dotted line. The fact that it's a dotted line means it's not F or H. It doesn't have the or equal to. So it's either G or J. So we want to see if 0, 0 works. So if we test out 0, 0, is 0 greater than 0 minus 3? Yes. So if this were the case, then 0, 0 would be shaded. But 0, 0 is not shaded. So this one should be the one that works. So let's check 0, 0. 0, 0 should make this one false. Is 0 less than 0 minus 3? No. So that would be letter J. And then notice it's shaded below. Less than kind of gives you that below area. Greater than will give you above. So this matches with letter J. And finally, let's do that bonus question. Find the value of k, so the slope from 4, 2 to k3 is 1/6. Okay, so we're going to use our slope formula, but instead of m equals, we're going to do 1/6 equals, and then y2 minus y1, so 3 minus 2 over k minus 4. So let's reduce the right-hand side down. So 3 minus 1, or 3 minus 2 is 1, and then over k minus 4. So we know that this thing is supposed to be equal to this thing. Well, notice that the 1's are already equal. So that means we need to take 6 and set it equal to k minus 4. Okay, so quick addition on both sides, and so we end up with 10. If k is 10, then the slope between them would be 1/6. All right, that's it for chapter 2.